Okay, welcome back to our Tic Tac Toe demo video. So, let's see, right now you're looking at the Unity 3D editor, and the Tic Tac Toe project is being displayed now. Let's see, so the way we went about this design is the project was broken up into 4 components. The components were the aesthetics, the game mechanics, the AI, and the configuration. Now, what we're going to see now first is the aesthetics. That's the part of the program that shows the graphics, the video, the scenes, the ships, the asteroids, all the wonderful gooey wooey stuff that the game player will see. And once we build these components, now we have all the building blocks. And then we have to orchestrate those building blocks. And the way we orchestrate the building blocks is by developing the game mechanics. And that has where all the rules are of the game, how things interact with each other, how you get from one scene to another scene, and so forth. Then there's the AI, and that will describe it interacts with the gameplay just like the player does. And then there's the configuration, which is information that's maintained globally among all the scenes so that the game engine knows what to do. Okay, so let's first look at the first scene. And the first scene is the home scene, is what you're looking at right now. And there are 5 scenes total, as you can see in the asset scenes editor down at the bottom of the screen. There's the game screen, the game scene, the home scene, which you're looking at now, the level scene, the mode scene, and the player scene. So with the mode scene, with the home scene, you'll notice that there are, you're looking at the screen and you see a background. You see 5 buttons. You'll see a display message saying loading. And then you'll also see in the hierarchy there, in the middle of the screen, you'll see that it talks about a background, buttons, display message, home controller, lighting, and the camera. Well, lighting is a basic thing. Really won't go into much of that, but as you can see, there's typical fill light, main light, and rim light. And this creates the effect of what you see when you look at the ship. So that's pretty much the same throughout all the scenes. And then there's the camera view. Now, the camera view is very interesting. Let's go into the scenes mode, and we'll look at the main camera. All right, so let me back away. And let's try to position this a little bit so you can see what's going on a little better with the camera. All right, let me back away some more. Okay, there we go. All right, so now the view that we're using is called an orthographic view of the camera. That means the camera is looking down on the gameplay. So now what happens is that if I move anything in the Z direction, you won't see any difference. It doesn't look like anything has changed. It doesn't really get smaller like it's far away, or it gets bigger as it gets closer. It's just the perspective doesn't change from the state of the camera. It looks the same. So things will change in the X and the Y. And this works out really well for a 2D type of display. All right, and if you look down at the corner there where it says camera preview, you could actually, this is what you're looking at. And this is what it looks like where the camera is. All right. Okay, so there are a series of buttons. I can try to show you the buttons, but you're not going to see very much. You'll just see an icon that represents where the button is, because the button is rendered at runtime, so you won't see it. It just shows you that's where a button is. But there are all the characteristics of a button. There's a caption text. You can see here it talks about the color, the font size, and the rotation of the text, the location of the text, and so forth. And you'll also notice that there's a script attached to this text. And we'll go over what that script is in the next part of the video when we talk about the game mechanics. All right, and you'll see that there's also a script for the panel frame. All right, and together this is the exit button, the mode button, the player button, the skill level button, and the start button. This is the display message that you saw on the screen that said, let's go back to here. You'll see where it says loading. That's the display message. Okay, and here's the home controller. Now, you need to have game objects in order to attach anything that you're going to use in Unity 3D. So this particular game object is nothing more than an empty game object. And its sole purpose is there just so that I can attach an audio source, which is a button press sound. So when we press on the buttons, you'll hear like a clicking sound. And it also allows us to attach a script. And the home controller script is the script that is the main program for the home scene. All right, so let's reuse there. And now let's move on to the game scene. Here is the game scene, and you'll see, when looking at it, you'll see there's your Tic Tac Toe pattern. You'll see there's a background that's supposed to be a nebula effect. There's two buttons. There's a reset button and a done button. We've shown you in the game what they do. And then at the bottom there's an item. That essentially is just a placeholder. That's where you see the player name saying player 1's turn, Goombot's turn, and that it's a draw or who wins. All right. And now we're going to talk about some of the assets that were created with the prefab. All right. So let's go into the prefab area, and you'll see that these assets here are generic assets that I built from. These assets came from the Unity 3D Space Shooter package, and it's something that they offer for free, and there's a tutorial and so forth. So I took their assets, and then I added value to those assets by adding scripts, sounds, and so forth, shapes, mesh colliders, and scripts, and so forth. So you'll see that the assets that I had to create are the alien ships. Okay, so we'll bring one of them into the scene now. That's the alien ship. You'll see it down at the bottom. All right, and what there are 6 ships, alien ships. As you can see their location. And this seemed to be the easiest way to do it. I could have made one ship and then just positioned it in a different place. But it just seemed then if I did that, then I'd have to find some way to encapsulate the information so that if I have to change something about a particular ship or an area, I have to do that, and it all ends up in the same file. So I wanted to keep it separate, and then the most natural way to keep it separate and encapsulated is to keep them as separate game objects. Just put them on the screen, and then when it's time to use them, you just instantiate them, and then they appear. And when you're done, they go away. You don't have to worry about coordinates. You don't have to worry about anything. You just know that they're part of the game mechanics, and they're part of the aesthetics, and the game mechanics will call those aesthetics accordingly. So you see there's 3 on the bottom, and you see there's 3 on the top. And I did this because it gives it a better effect when the asteroids are far away. Well, you want to make the asteroid far away, so at least you see the ship, you see some laser fire, and you see it gets to there. If I had put the asteroid, if I just kept the lower part, anytime the asteroid's on the lower part of the screen, they just blow up immediately. So you really won't see much of the ship, you won't see anything. So that's why I have them coming at from both directions. So the aliens, or the AI in this case, which is Goombot's ships, come from the top and the bottom. All right? So that's the assets for that. Followed suit. Let's look at what these things look like. So let's pick any one of the ships. All right, so let's pick this one. We'll go to the scene editor and we'll bring it into focus. We'll back up a bit. And as you can see, you see the game ships in, you can see them when I change the perspective where they are. You'll also notice that they're above the background, not sitting in the background. The reason for this is that if I had them sitting at the same level as the background, then the ship's perspectives will look muddy. The colors will look muddy, things would look muddy, because there's interference with the rendering of the background. So I keep them on different planes, and then everything looks clear, and it gives it a bit of a 3D look. It's subtle, but it's there. So as you look at the ship, you'll see that there's this border or boundary around it, this blue thing. That blue thing is called a mesh collider. And if that barrier is penetrated by any other game object, say a laser bolt or so forth, it activates a script. And so it's an on-trigger script, on enter. And that's why you'll see that around the entire ship. So the thing about this is that you have a game object. In order for it to be an entity within Unity 3D, you have to give it a rigid body. And you'll see off to the right that we've added a rigid body component to the, there's a mesh renderer. So you have a game object, there's a mesh renderer, which essentially is showing the skin. And then there's a rigid body that's given to it. That's where the game mechanics, physics takes play. So you can actually add gravity and so forth. But because we're in space, you really don't want gravity, or else this thing would just fall down to the main. It would just fall like down off the screen, which is what we don't want. So you also see there's a mesh collider, and the is triggered event is activated. You also see that there's an audio source, and this audio source is weapons fire. And you'll notice that I don't have play on awake checked or loop checked. And the reason for this is because I don't want it to continually play in a loop, and I don't want it to start firing lasers when it first comes into view. All right, so you'll also see there's a script attached, which is the C player collider script, and that script is specifically designed for the collision of the stuff that the laser bolts that enter the ship collider area. Right. So there's also a another script, and this is a you'll see an audio source. And this is for when the ship appears. You'll see that there's play on awake, and this essentially is an effect that says the ship has appeared, and it gives it sort of like a boom type of thing that the ship has appeared. Same thing as you watch these sci-fi movies, and they're coming out of hyperspace. Okay, that's that sound, and that's why here I have it play on awake, because when I instantiate the object, it plays that sound, and it's as if it came out of hyperspace and it appeared and starts working. So that's why that's there. At the bottom, you'll see what the skins look like, the components, and that's the materials and so forth, and that's what makes the ship. All right, so that's what the Goombot's spaceships look like. Okay. We also have a game object in this scene called background music, and that's where you hear the beat and the music, and that's playing, and that's checked for a loop, and it's checked to play on awake, and that'll play continuously. That's why you hear the music. The background we talked about, that's the nebula. As we pull away, you can see the nebula. All right, so let's pull that. See, there's the nebula down at the bottom. All right, that's the background. Then there's the board controller. This is just an empty game object that's designed to hold things. In this particular case, this is where we attach all the asteroids to the scene. And here's where we map the actual physical assets to a variable within the script in the C board controller script. And so we access the variable. When we access those virtual variables, we'll actually be accessing the assets and be able to do things. And this is just a way of entering the assets. All right, and you'll see them here. There's the asteroids, the marked ship, the marked plates that show X and 0, the alien ship, and the human ship. All right, and it's a button press sound and so forth. It's pretty standard. Now, this other thing here is called a boundary. As you can see, the boundary encompasses the entire plane area. All right. The reason for the boundary is this boundary is a cube mesh filter. It's also a box collider. It's a cube mesh filter, but because I want it transparent, you really don't see anything in there. It is triggered, and this box collider is there so that when you see the enemy ships passing in the scene, once they go off screen, they're still going off screen. They're continually in the virtual world. They haven't been destroyed. Just because they're out of sight, that doesn't mean they're out of mind. So what happens is that as soon as they penetrate this box collider boundary, which is on exit, then what will happen is an on exit event. Then what will happen is that the ship and the laser bolts are destroyed, so that the resources are freed up and they're gone. That's why there's this box collider, and that's the boundary. All right, here's the buttons, the done and reset buttons down at the bottom. Here's the horizontal lines, both of them, and typical lighting, main camera, and the vertical lines. Okay, the vertical lines are nothing more than a game object with a picture on it. So you don't see much because these things are rendered at runtime. Okay, so that takes care of those components. Now let's put in the, let's show you what the asteroids look like. Okay, so here's a typical asteroid. We'll bring that into play. All right, let's bring that into the main focus. And let me get rid of the alien ships. The alien ships, actually Gumbat's ships. So let me remove those ships from the scene so that we can focus on the asteroid. Okay? All right, so here's the asteroid. And like I say, it's in the main scene, and we'll just move it around. Okay? It's at the same level as the asteroids. In this case, are they're actually at the same level as the spaceships. The problem is that the asteroids will rotate, and when they rotate in a non-symmetrical fashion. So they go in and out of, they move up and down in the plane while they're rotating. So there'll be times when the ships will go underneath them, the ships will go above them, or the ships will go through them. It all depends on where they happen to be at the time. So this is like the Gumbat's ship. You'll see that we had to add a rigid body. This uses a capsule collider, which is the shape of the collider because it's an asteroid, and the capsule collider is more appropriate for the type of asteroid. The capsule collider works the same as the box collider, works the same as the mesh collider, and so forth. It's there so that when a laser bolt penetrates that collider boundary, it triggers the on-enter event of the destroyed by contact script, and the asteroid will just destroy. It'll execute it'll instantiate the explosion game object, and then that's it. It's gone. It goes off the screen. It gets destroyed. Right? There's also another script called the random rotator script. that's what puts the object in rotation, and we're taking advantage of game physics, the physics engine within the game. All right, so that's with the asteroid. Okay, you'll also see that there's an audio source of a button press. For the most part, in this particular game, that asteroid is a button. And when you press on it, you want to have a button click sound to show that you did touch the asteroid. And that's where the press button sound is. And when you touch the asteroid, that instantiates the spaceship, and then the spaceship does its trajectory and takes out the asteroid. Okay, so that's the asteroid. So let's remove that. And the asteroid, you'll see that there are 9 asteroids for each of the blocks. And I'm using the same concept as I did with the ships. It's just easier, and it encapsulates all this stuff, information, in the game object for the particular thing. And it just makes it more transportable. So I can take these game objects and use them anywhere in any other scene or any type of game, because these game objects really have nothing to do with Tic Tac Toe. All right, they're just assets, and that's the best way to create the aesthetics, so that as a game designer you can reuse the aesthetics, and then you could make different derivations of the game. Like Angry Birds has Star Wars version of the game. Angry Birds has the Rio version and so forth, to use an example. They're using the same game assets. All they've done is change the mesh, the skin. It's the same game objects. It does all the same stuff. Everything is there. All right, so that's why there are 9 asteroids. Okay, so let's get the asteroid off the screen. And now let's show you, we have the human ships. These are your ships. And we'll put one of them on the screen. We'll bring it into focus. And then we'll just manipulate it so that you can see the ship, the human ship. Okay, and there it is above the scene. All right, and let me go to the game view. You'll see it's there on the side. And again, using the same concept as Goombot's ships, there are 6 human ships, and they come in from the sides. And it's the same philosophy of dealing with it, where they're on either side because of how it executes the asteroids. So they look the same. The ship is no different than a human ship, is no different than Goombot's ship or anything else. It has a mesh collider, and if you penetrate that mesh collider with a laser bolt, it trips the on-enter event, and the ship explodes. We talked about the box collider. That's the boundary, and this will penetrate the boundary, and then it'll go away too. All right, so that's these assets. Let me get rid of these ships so they're not in the way anymore. Okay, so they're out of the scene. And now we'll talk about the plaques that you see. So we'll bring them up. Now the problem is that I really can't show you these in the game view, in the scene view, because they'll just look like they're rendered objects. Okay, you'll just see that. But there are characteristics about that. There's a panel, all right, which is a gooey texture. That's the panel that you see, and there's a sound clip that's attached to it. All right, and then there's a text that shows either an X or a 0, and that's what that's there for. And then that's where you'll see that determined character mark. Okay, so based on whose turn it is, a 0 will appear or an X will appear. All right, if you're player number 2, whether you go first or second, you'll always see a 0. If you play number 1, you go first or second, you'll always see an X. All right, so that's that. And so let me go to the game scene, and you'll see there it is. It looks, like I said, it looks a little awkward. I mentioned this in the video of the game. It looks a little awkward, but that's because I had to make it a little skewed so that it appears fine on a Nexus 7, which is the device that I used it for. This is the simulator. If I made it perfect for the simulator, it looks a little odd in the Nexus 7. I noticed that's one of the drawbacks I just noticed with Unity 3D and how Android deploys this stuff. And it also has the same problem with iOS and so forth. Okay, so that's the plaques. Then here are all the sounds. We have the happy sound and the sorry sound. Now the sound is attached to a game object. Remember, you need a game object to attach these things. So when the game is over and the player wins, a human player wins, you'll hear the happy sound, which essentially what I'm doing is I'm instantiating the game object. The game object has play on awake and it plays the happy sound. Okay, and then the game object gets destroyed after a certain amount of time. All right, same thing with the sorry sound and so forth. All right, so that takes care of the game scene. Those are all the components of the game scene. So we're going to move on to the configuration part here, which is the level scene, the mode scene, and the player scene in part 3 of the video. All right, so we'll see you shortly. Thank you.